Very good morning, friends. Today we will see the fourth problem in kinetics. So this is the problem. The problem I will define it like this. You see the problem. There will be two blocks A and B. It is A is on a slope of 30 degree and B is on a slope of 60 degree. It is connected with a string through a pulley, frictionless pulley. Now, this body A having a weight of 500 Newton, body B is having a weight of 1500 Newton. So, the mass of body A will be 50.968 kg, mass of body B will be 1500 by 9.81 will be 152.904 kg. Right, the mass, weight, and the coefficient of friction between the blocks and the floor is 0.3. It is given. So now, what is asked? The block is starts from rest, and after 5 seconds, what is its velocity? So in this kinetics problem, we will be getting the acceleration first. So from the acceleration, using the kinematics equations, I can find out the final velocity after 5 seconds. So that is the strategy. So how to solve it? In this problem, we will find out the acceleration of the body. Now, body A and B is connected through a string. Since it is connected to a string without any difficulties with the frictionless pulley, the body A and B all together will move in the same acceleration. Body AA is same equal to AB is equal to A acceleration, right? So that acceleration, what is that acceleration? How we can find it out? It is simple, similar to the previous problem. You consider this slope first of all, and you terminate this as you will be having a tension here, you will be having a tension here, and the body is moving right like this because body B is having 1500 Newton and it is having a more steep, right? So now body I have considered. In body A I have drawn and the slope will be x-axis, perpendicular to that will be y-axis. So the body A weight is 500 Newton acting downwards, and the normal reaction will be perpendicular to the contact surface, and this 500 Newton I can decompose into two components. One is 500 cos 30, that is equal, that is parallel to y-axis, then 500 sine 30, this one, that is parallel to x-axis. Apart from that, the body, since it is moving this way, there will be in the opposite downward direction there will be a frictional force. What is the coefficient of friction? 0.3 into n1. And since the body is moving, I have to keep the body in dynamic equilibrium condition. For that, I have to substitute an inertial force, that is ma into a, that is 50.968 into a. Ma is mass into a. Now, by solving this for an equilibrium conditions, dynamic equilibrium conditions, the force, the N1 will be equal to 500 cos 30. So that is the first equation. You can see N1 is equal to 500 cos 30 is equal to 433.013 newtons. Then T is equal to the downward force. What are the three forces I have? T is equal to T minus 50.968 A minus 0.3 N1 minus 500 is equal to 0. That is my 500 minus 500 sine 30 is equal to my 0. So you see here T minus 50.968A minus 0.3 N1 minus 500 sine 30 is equal to 0. So T minus 50.96A is equal to this one. If you substitute this N here, I will get a constant. 500 sine 30 will be 250. So adding these two and I am taking to the right side, it will be 379.904. This is my first equation for the first block. So you have got that. We will consider the second block which is in the 60 degree inclination plane. and I'm considering the slope surface as x-axis and perpendicular to that as y-axis. So then the tension will be acting upward T, then normal reaction perpendicular to the contact surface, that is N2, then weight will be acting downwards, that is 1500 Newton. So I can decompose this as 1500 cos 60 equal to parallel to y-axis, 1600 sine 60 parallel to x-axis. So since the body is moving downward, so there will be an upward frictional force, that is zero point 0.3 N2, and to keep this body, since it is moving, to keep this body in dynamic equilibrium, so mb into a I have to substitute in the negative direction, negative moment direction, that is 152.904 a, mass of b is 152, so into a. So this is the condition for second block. In this block I can find out the vertical equation, I can equate it to 0, that is n2 y-axis, n2 minus 1500 cos 60 is equal to 0. So I can find out n2 as, n2 as 1500 cos 60 is equal to 750, is equal to 750. N to 1500 cos 60 is 0.5, so it will be 750. So in the second block, you can see, in the second equation you can see summation of x-axis equal to 0, that is t minus 1000 t minus t plus, sorry, it is t, this way forces, this direction forces equal to downward direction forces, that is also same. So t plus 0.3 and 2 plus 152.904 a is equal to 1500 sine 60, right? So that is the second equation. So in the second equation you can see T 152.904 A plus 0.3 N2 is equal to 1500 sine 60. So T plus 152.904 A is equal to this N2, I can substitute it here, 750, that is 0.3 into 750, and 1500 sine 60 will give me 1074.38. This is my second equation. So first equation will be T minus 50.968A is equal to 379.904. This is my first equation. From the first block, this is from the second block, this is from the first block, this is from the second block. So two equations, I have two unknowns T and A. I can very well solve it in calculator for two unknowns. T, you will be getting it as 553.523 Newton. A, you will be getting it as 3.406 meter per second square. Sorry, meter per second square. Now, what is our acceleration you have got? What is our, after 5 seconds, what is the final velocity? Since the block is starting from rest, the initial velocity will be 0. So, using kinematics equation, B is equal to U plus AT. U will be 0 plus A will be 3.406. T will be 5 seconds. So I will be getting V is equal to 17.025 meter per second. That is the answer. Thank you.